on. Yeah. All right. So first things first, let's talk about our panel today. Guys, if you want to just kind of go around in circle, introduce yourselves real quick, you can do that, and then we'll get into it.
I'll go first. I'm Jim Vajda, Chief Wireless Officer at 7Signal. Been here 4 years. You can see all my certifications there on the screen, and I'll throw it to Eric.
All right, Eric here. You guys might recognize me from 7 Minutes with 7Signal, but head of customer success here at 7Signal. So I interact with our customers and the systems that they've acquired from us every day and all the time. Happy to be here.
And I'm Chris Couch, and I just hit my first full year with 7Signal, so super excited about that, and yeah, looking forward to this.
Awesome. All right. Well, let's get into it. So just like last time, I'm going to have a stopwatch. We'll see if we stay committed to it. We're going to have 5 minutes for each question. And we'll try our best, guys. All right. So question number 1, we're going to have Jim Vajda answer this one first, and then we can open it up to the rest of the panel for any thoughts and feedback. So this was submitted by IHAM, and I'm sorry if I mispronounce any of your names. But the context here is that there's an AP connected to 2 Wi-Fi extenders to increase coverage with the goal of the best seamless roaming experience. What is the best position for range extenders? Is it only based on RSSI? What value is accepted, and is there an overlap percentage there?
All right, so there's 4 questions here, so I get 20 minutes, right?
Oh yeah.
Wow.
Wink, wink, nudge, nudge. Yeah.
So a couple things to start. I would not use Wi-Fi extenders in a business setting or in any kind of enterprise Wi-Fi setting. Just that should be just kind of off the table. The reliability is not good. One of your goals is seamless roaming, and a Wi-Fi extender is going to create its own SSID. So there won't be any roaming between that and the sort of base AP. The user will have to choose the other SSID to connect to, or wait till its signal has gotten so poor that it, disconnects and looks for another SSID. So not good for roaming, and really not good for performance either. The maximum throughput you'll get with a Wi-Fi extender is half what you'd get from the base AP. And you're also creating sort of this RF daisy chaining thing. And that's just, really going to make reliability a problem. So I wouldn't do it. But to give you a direct answer to your questions, the best position, it takes a little bit of experimenting. You can use RSSI for that, but I would rather use MCS if you can get that. You want to set the extender sort of as far away from the base AP as you can get while still maintaining very high transmit and receive MCS from the extender to the base AP. And then, you want to go to that proposed coverage area with a client and see if it also has very high, MCS on transmit and receive. And if you've achieved that, then that's about as good as it's going to get. But and then the last thing is about overlap percentage. There's some AP vendors say, hey, you should have 25% overlap between your coverage cells or some percentage number. And I find that really confusing. How on earth would you calculate an overlap percentage between 2 AP coverage cells? It's kind of an unsolvable problem, especially in the real world. Our coverage cells are not circles. They're, do a site survey, you could see the crazy coverage patterns that AP cells give you. So an overlap percentage is kind of meaningless. What you really want to use is kind of a minimum RSSI, and a secondary AP RSSI, and validate that you have those signal strengths everywhere where particularly where clients are going to be roaming between APs. So don't use Wi-Fi extenders, run Ethernet and install a second AP. If you can't do that, is there other cabling? Is there coax? Is there power lines? There are options to get wired Ethernet over those as well. And then if that's not an option, a mesh system, I really wouldn't want to use that in a professional setting though. So spend the money and run some cable.
Good advice. Thank you, Jim. Yeah, I got rid of my extender years ago, and I've been much happier ever since.
What'd you replace it with, Eric?
Another access point.
There you go.
Yep.
Sorry, I couldn't get the mute button, the unmute button to click. Okay, awesome. Well, we're doing good on time, so I'm going to go ahead and proceed to the next question unless anyone have any last thoughts on this one.
No, I just agreeing with everything that Jim said. There's not a whole lot more you can say.
Right.
Yeah, and I'll just say this, you know, mesh networks, I mean, you got to be careful. Also, the gentleman was referring to, you know, the ability to roam, and you know, a lot of people, they spend a lot of money on these mesh networks and they're not roaming from one to the other like they maybe think they are. And so, you know, there's other problems there as well with trying to get coverage.
Yeah.
Yeah, latency just goes through the roof when you deal with stuff like that, especially with authentication.
Yeah.
Absolutely. Yeah.
Every hop you add just adds more to it.
Right. Good stuff. All right, moving to question 2, which was submitted by Jonathan. What are the core questions to ask the Wi-Fi users in order to glean the best information to more efficiently troubleshoot Wi-Fi issues? Chris, we're going to throw this one to you first, and then we'll open it up.
Yeah, Jim and I were talking about this because we were looking, actually, we both took this question in different directions. One was the overall site, and the other was actual like individual users that may be having problems. So we were trying to think of the best of both worlds. And if you think about the individual user, you know, asking technical questions to them probably isn't going to get you real far. So really understanding the use case that they're having the issues with, whether it's an application, or is it, you know, is Citrix failing, or is, you know, web failing, or were you in a specific part of the building, you know, asking generalized questions around that before you get into the more technical pieces of it. Or if you're going to, as Jim was alluding to, was going to ask the entire site how their experiences are. You know, would you ask very generalistic questions, Jim, you think, for a site?
I would. Yeah. I mean, it's sort of, that kind of depends on what you're after. I definitely agree with the point that, you know, you should just ask them questions that they're prepared to answer, and, you know, kind of leave the Wi-Fi jargon out of it. And if you think about it, like an end user that's not technical, and you know, they're using Wi-Fi and they're interacting with applications, and what they can tell you with some certainty is like, hey, the Citrix, I was in Citrix and the screen went black, or, you know, it started getting really laggy, and it happened at this time and lasted this long. You know, they could give you pretty good symptoms of, you know, poor application performance, which may or may not tell you something about the Wi-Fi, but it kind of gives you a starting point as to when to look for issues, and what some of those problems were. They can tell you where they were at the time. Of course, that's useful too. But, you know, ask them questions that they can answer specifically. Wi-Fi is an interesting thing too, because it's, you know, when Wi-Fi is performing really well, it's like the lights and the HVAC and the plumbing. You don't think about it. The lights come on, you're doing your job. You're thinking about doing your job. You don't care about all the facilities infrastructure that's supporting you, until the toilet doesn't flush and the lights don't come on and it's 50 degrees in the room. You know, then you're really thinking about all that stuff. So Wi-Fi is like that. And, you know, if you ask people, hey, how's the Wi-Fi today? You'll either get a sort of, I guess it's okay, I don't know. Or you'll get, you know, an angry diatribe about the horrible experience somebody had. So
Yeah.
and yeah, you won't get a balanced sort of like, oh, the Wi-Fi was amazing and made me so happy today. You won't get that.
Yeah, well, that's, and I'll say this, using, Mobileye in that's where you get all your technical information from. You can get the general idea of what's actually failing in the environment from the client, and then use, the solution to be able to figure out what's actually going on without having to interrupt the customer, asking them all the technical questions when you have it all at your hands. So that's another way to look at it as well. Get the general idea, get as much data as you can about the problem, laptop related, whatever else, whatever devices they're using. But try not to, I try to get as much as I can without overloading them with the technical jargon, like you said, Jim.
Yeah, and my suggestion, I mean, a lot of people, they just blame the Wi-Fi for everything. So the first question that I would ask is, are you on the Wi-Fi network? Sometimes they're connected to a dock and they're using Ethernet. Sometimes they are, sometimes they aren't. It's just like
sometimes they're on a cellular network.
Exactly. Exactly. Sometimes they're on the cellular network and they're tethering, or something like that. So that's a good standard question that, I would potentially ask. And the other is, where are you? And are there other people having the same issue? If you can isolate it to, it's you, that does help, I think. Can you ask the person next to you, are they having problems with the Wi-Fi? It is just a simple question that will hopefully narrow it down to something going on their computer. As we know, I always try to cut the problem down really, really fast by asking, well, in my mind anyway, is it wired, wireless, or a client device issue? Okay, and so by asking the first question, are we connected to Ethernet, things like that. And it could be a device issue. It could be that your CPU is pegged. It could be, something to that effect. So without, like you say, getting into all of the jargon, a few things to try to cut the problem down to size, like, is anybody else having it? Are you connected to Wi-Fi? And just seeing that little Wi-Fi indicator in the corner of your computer and mousing over that to see what network you're on can sometimes be really helpful as well in narrowing down the problem.
And to your point, Eric, too, Bruce actually put it in the chat as really to clarify what the concerns are, because as you said, it could be cell, it could be Ethernet, it could be, many different things that they're going to blame the wireless for. If you don't clarify actually what the real problem is, you could be chasing your tail all over the place.
Yeah, you want them to give you the real symptoms they're observing, and not, unfortunately, a lot of help desk tickets are things like, the Wi-Fi's broken, go add an access point or something. It's like, wait, what's broken? Tell me what you're seeing, and then I'll figure out what the problem is. Or
a better term that I like to use is, tell me how it's feeling. Typically when I'm talking to somebody, how does the network feel? Does it feel slow or fast? Are you experiencing, is it choppy or jittery when you're talking? Which direction? Is it that people are complaining about they can't hear you properly, or is it that you can't hear them properly? Because that matters. We talk about upload versus download throughput. And if somebody's working remotely, there's a good chance there's an unbalanced link there. So how does it feel is a good question as well.
Bruce has a good comment too in the chat. He says, has it ever worked? I mean, sometimes you really have to just ask obvious questions. I've had this experience where I was troubleshooting a Wi-Fi problem for someone that was connected to a cellular network, and they never bothered to tell me that, or even maybe they were unaware. And similarly, I've had help desk tickets about Wi-Fi outages come in because the power was out at a site. And they didn't mention that in the help desk ticket, that the lights were off, the power's out, everything's off. Yeah, the Wi-Fi's down. Yes, because the power's out. It uses electricity. So, sometimes you really got to start with the most basic things.
Yeah, like I was saying a moment ago, do you see that little Wi-Fi indicator in the corner of your computer? Can you mouse over it, please? Super simple.
Yeah.
I like Andrew. Andrew, it's wireless. It's not powerless.
All right, guys. Thank you, panel. You may have noticed the question has changed as we must move on. It's so easy to get tied up. One last thing, because I saw this comment from John, and I just think in troubleshooting anything, it's really easy to jump right into getting really technical about it, but it is about asking more simple questions. Like John said, what's changed recently? That can give you so much insight into, what changes have been made in your environment or on your device. And I think that can point to really good insight. But all right, let's move to question number 3 here, which was submitted by Pete. So are there any tools available at this time for scanning Wi-Fi 6E or 6 gigahertz channels and reporting or displaying what channels are in use? And I know Jim's about to pull up his favorite tool.
Yeah, I can think of 2, and I want to invite people in the chat if they know of more to share them with us. The first is the new Ekahau Sidekick 2 that's got 6 gigahertz radios and can do scanning. Maybe what's more accessible is the WLAN Pi Pro that I got at WLPC last year. This has 6 gigahertz radios in it, and you can actually use it as a remote sensor with Wi-Fi Explorer. So Wi-Fi Explorer runs on Mac OS. There's no 6 gigahertz support for Mac OS yet, but Adrian's updated that software to support 6 gigahertz scans from this and maybe some other sensors too. I'm not sure what else might be out there, but Wi-Fi Explorer and the WLAN Pi Pro are what I use.
Anything else from the panel? I'm looking at the chat.
Oh yeah. Elaine brings up the AirCheck G3 that just came out last year too. That supports Wi-Fi 6E as well.
That'll cost you a pretty penny.
Indeed.
All right.
View for Wi-Fi by Tamsoft. I haven't heard.
I've never heard of that.
I'll have to take a look at that.
200 USD per year. Speed. All right. Good on time there. Kind of made up for the last ones. Moving to question number 4, submitted by our friend Steve Blunt. Has anyone you know of developed a single app or web utility that's free or simple to determine the MCS rates of all common vendors OS?
No. Next question. No. So it's I mean, not really. If you're going to say all common OS vendors, you got to include iOS. And really, if you want to get the MCS rates for an iOS device, just do a packet capture, right? So, and that can give you the MCS rates for anything on the channel from any other device. So I would say, packet capturing on a Mac you can do for free, and that can show you the MCS rates of the devices around it. Certainly, if you want something more enterprise friendly and available, remotely, 7-Signal Mobileye is a great solution there.
Yeah, absolutely. I mean, you're not going to get it from Windows, right?
No. Yeah, Windows doesn't create the MCS rates. You can't get that out of Windows. We have figured it out with Mobileye to get it from Windows devices, without doing packet capturing or anything fancy, just with our Mobileye agent running on those boxes. So
the one thing I will say though is, depending on the application you're using it, even if you're kind of outside of this, when you look at those free tools or shareware versions of things, just make sure you're aware of the situation you're using it in. Because if you're using it in a commercial environment and you're using a shared version or something that's a licensed version, you can find yourself in some trouble there. So just be real cognizant of how you use those tools, that you're not using them in a commercial setting, because you can put yourself into some legal issues with that.
Yeah.
So just be careful.
Yeah, the terms and conditions are often make a big distinction between, personal and educational use versus using in a commercial setting. So careful with that.
And we have a comment in here from Martin. Tamasoft is highly recommended. Have you guys heard of Tamasoft?
Heard of them, yeah.
Awesome. All right. Move to question number 5, which was submitted by Andrew. Have you found any consistent ways to determine that oversaturation is the cause of an issue? We'll throw this to Chris first.
Oh, that is a good question. We were talking about this, and really, besides just listening to channel utilization and sort of things, and really using Sapphire Eye to really figure out a lot of this. I don't know of another real way to really think of that besides how the performance of the devices are and what's going on in the environment. Jim, when we were looking at this yesterday, what did we see besides the airtime utilization and the QBSS station load stuff in the Sapphire Eye were we looking at?
Yeah, airtime utilization, QBSS channel utilization, so you can get the view of the AP and our sensor to look at how busy the channel is. You know, one of the things that's interesting too is you could have very high channel utilization in a totally healthy network. It's just the channel is the bottleneck, and somebody's doing a huge file transfer and you're trying to get it to go as fast as possible. So you're using all the airtime that's out there, and that's not a bad thing. That's actually a very efficient use of the available resources.
And Jim, what would you say is a high utilization rate? Are you thinking like in the 50s?
Well, I would say, you know, if it's kind of spiky, like doing that download I talked about, it could get up into the 70s and 80s. But kind of, you know, what you want to look out for is that chronically elevated channel utilization. Sort of think of channel utilization like blood pressure, right? If you're doing a bench press or exercising, your blood pressure's spiked while that's occurring. But that's good. It actually helps you, you know, it's a healthy, you know, biological function. But if throughout the day your blood pressure is always, you know, higher than a typical, you know, a healthy range, that could be really, really bad and really unhealthy and probably needs some intervention. So, you know, you want it to be as low as possible when there's no traffic on the network. And when there's traffic, you know, it's I think that 50% number is a good threshold for when voice performance starts to degrade. So you don't want to see it consistently that high for longer than that. And then I'm sure, you know, in environments like large public venues, it's, you know, it's a constant battle, right?
Yeah. You just do whatever you can.
Right. When it's really busy in an environment like that, it's very high density, you're going to have really high channel utilization. What you want to see is retry rates that are under control and high MCS most of the time to make the best use of the channel.
Sure. And, you know, you were talking about high density, and you got to really watch out for the management overhead traffic, right? The probe requests and probe responses. And so I know that there are they're familiar with that receive start of packet feature, that, you know, RX SOP feature, right, Jim?
Mm-hmm.
You can actually control and gain back maybe just a couple % of airtime. And in doing so, really fundamentally, depending upon the environment, of course, fundamentally, improve overall the quality of the air and the ability to have a good experience.
Yep. Definitely careful channel planning will help. And advanced features like RxSOP, spatial reuse, and probe response suppression is gonna help too.
Awesome. All right, panel, moving to question number 6 submitted by Bruce. The situation is about timeouts on client authentication requests. What is the best way to determine if it is a radius authentication issue or a radio interference issue? Jim, we'll start with you.
Yeah, and thanks for the question, Bruce. This is interesting. So radius authentication, those frames are transmitted over the air at the minimum basic rate. So they're using a very robust modulation, and they're also acknowledged. So if a frame's not received, there should be a retry. And it's so what I'm getting at is there shouldn't be many situations where the RF link is actually causing EAP messages not to reach a radius server or actually not to reach a client. They'll be retried. They're using a low data rate. It should get through. And if that is the case, then I would think the overall performance of the Wi-Fi is going to be really poor, if even that is suffering from it. How would you go about looking for that? I would, you could look at controller logs. I think you usually get better logging from radius servers directly, like ClearPass and ICE. They both have nice logs where you can look and see all the packets going back and forth from the server from a specific authentication session. And then you can see like who sent the last message. Why did the timeout occur? Is the radius server waiting for the client, or is the radius server, retrying something it's sending to the client and not getting a response? And then, depending on what you find out from that, you can go look at something else. But those are my thoughts. Probably as a intermittent problem too, right? If it's not constantly happening where it's easy to troubleshoot, that's probably why you're thinking about RF interference. So, the Sapphire Eye can help there too, because it's doing 24/7 monitoring of radius authentication. So it can help you find those problems too. Chris, did you have any thoughts on this one?
Yeah, I was really thinking, through the different phases of radius and, what the Sapphire Eye actually can show you on the timing for each one of those will probably give you a little bit deeper understanding of where that issue may reside, whether it's, response from the radius server, maybe it's the certificate timing out, something along those lines. But you're right, the logs in those tools definitely give you a very good overview of what's happening. Sometimes you just get that timeout message, and that's where the Sapphire Eye comes into play, because you can see where it's failed in that process. But yeah, I would see that more in a phased approach of something that's failing rather than an interference because of the retries that it's going to try to do. So,
and don't rule out the controller as a possible source of the problem. The controller is relaying messages back and forth between the radius server and the client, and maybe it's sending messages to a bogus IP address, or it's dropping them because of a bug or something like that. That could be, that's definitely a link in the chain to be observed too.
Mm-hmm. Yeah, absolutely.
And just so y'all know, we are getting a couple of questions in the Q&A panel. I think we'll try and save those to the end. So I know you're throwing some in there. We'll see if we have some time at the end to go ahead and answer those, but want to get through our first batch here. So moving to question number 7, which was submitted by Nick. What are some of the common symptoms of an unhealthy wireless network? And what are the top 3 ways to improve the network health? Jim.
Common symptoms of an unhealthy wireless network. High retries, low MCS, and high channel utilization. Those are Wi-Fi metrics directly. Of course, and certainly those are things that we measure and keep a close eye on with Mobileye and Sapphire Eye. In terms of things that are observable by end users, it's poor VoIP performance using collaboration apps like Teams and Zoom and FaceTime and things like that. It's disconnect and page load errors on websites and things like that. Kind of the sort of more performance based problems that could have other, as we know, and often have other root causes, like an issue with the internet circuit or the wired network, things like that, or the applications directly.
Roaming.
Yeah, roaming. certainly. But so there's kind of like those symptoms that end users can observe and tell you about, and then there's things you can measure directly. So hopefully give you some ideas there. Anybody else want to jump in?
In terms of ways to improve, I always remember Keith Parsons' advice as like the first thing that he looks at, examines, and probably turns off, and that's radio resource management or ARM or RRM. If you don't, in terms of a way to improve network health, I know that at 7 Signal, we're big fans of the static channel plan. We realize not everybody can do that, but taking a look at those settings, taming it, tweaking it, controlling it, I think is one of the simplest ways to improve the overall health and wellness of your Wi-Fi network. Jim, Chris?
Yeah, no, it's great advice, because if you got APs that are flopping channels all over the place and changing powers, you're changing cell sizes, you're introducing all different kinds of things to the client that they have to adjust for. So if your environment's not stable in the first place, and not by your own doing, by the controller trying to fix it, then yeah, absolutely, that's the first place you want to take a look at and really bring it under control.
Yeah, and I would add just the top 3 ways to improve network health. You have to have a great or a decent Wi-Fi design. So it's your channel plan, and everything else that goes into design. You have, like, that's a bare minimum. Make sure you have enough internet throughput to support all the internet traffic that your network is generating. And then standardize on your clients. Everything falls apart if you've got clients with bad adapters and buggy drivers. So
yeah. And we're seeing a lot of, I'm sorry, Chris.
No, you're fine. Go for it.
We are seeing a lot of problems with mixed environments now in terms of client devices. The Windows PC ruled the enterprise for decades. Now we're seeing more and more MacBooks in the enterprise. And whether it's 10% of the fleet or 20% of your fleet now, this is causing a lot of issues for people who are who have what they thought was a pretty solid design. But these Apple computers and the Intel based adapters that are in PCs, they perform radically different. And so therefore, trying to design a network that can meet the needs of both, oh my gosh, I don't know. I think it's impossible.
Yeah. And a lot of people have that challenge. Scott in the chat is mentioning, higher ed, where everything's BYOD and you got to kind of do the best you can. Right. But yeah, if you can't do that, you are going to have to deal with a little bit less overall reliability.
Yeah. And that, coming to design and BYOD as well, when you think about, being able to, when you talk about channel utilization, channel widths, and then supported channels in that aspect, if you're going to a BYOD environment, you may be turning on channels that those devices don't support and actually causing more problems. Or, where do you draw that line that just because of the oldest devices, if you're designing to the least capable, you're impacting the most capable at the same time. So there's a happy medium in there you have to worry about as well. What is your overall organizational standpoint on what devices you're going to support? In universities, you have to support everything, but do you have to support, all the way back to B and, those type of really old devices, or can you, is there a technology line that you can draw to make those determinations as well?
All right, before we get into question 8, since we're already talking about Apple, let's go ahead and answer IM's question. It's about iOS, not Mac OS, but it's how can I get iPhone RSSI value? It's easy on Windows, Android device, MacBook, but iPhone, I don't know.
It's frustrating. What the one way to do this is with an app from Apple called the Airport Utility.
Yeah.
Which is presumably for setting up Apple's long extinct airport base station hardware. But it has a button there called Wi-Fi scan. And if you hit that, you can hit scan and it'll, let's see if it's gonna, there we go. It'll show you the scan results just on your screen from the iPhone, including the RSSI of the connected BSS ID. So that's the easiest way to get it, which isn't particularly easy, but it's one path.
If you have access to the device, absolutely you can get it, but without it, yeah, not so.
Yeah.
Yeah, you can't export that, Jim, or anything, right? You can't email it to somebody. You can't do anything with that. It's just on your screen, right?
I think you can export a CSV.
Oh, really?
But then you have to kind of figure out what to do with it. And yeah, I can share this. And actually, I maybe like I could drop it to my Mac. And I think Wi-Fi Explorer will read it. But again, it's, kind of single point in time, iPhone in hand kind of troubleshooting.
Yeah.
All right, moving on to question number 8 submitted by Nick as well. So what kind of issues can occur when using DFS channels in 5 gigahertz, even if there are no radar events in the environment that cause channel changes? Do you have any broad guidelines about when it's okay to use DFS channels and when we should avoid their use?
Yeah, that's a great question, Nick. So it's really going to depend on the devices in your environment, what you have around you, and other equipment that's in the building. So if your device is supported, I absolutely say use them, and make sure that as long as the devices support everything. I think 144 will probably be your problem child with any older devices, just because that was introduced when the Dash Bs came out. But use what you can. Separate that airspace out, just make sure your devices support them, but also remember that, it's not only our radar events that will cause a DFS change. So there's other clients that could do it. There could be something else in the environment that can trigger that. You just need to look through the controller, look at those DFS events and validate, what has actually happened on those channels. But I'd say, if you have them, use them, just be aware of what's in your environment, and to make sure you don't, like I said before, if you enable something that your devices don't support, you're black holing all that traffic and then nothing's going to be able to use it. So, yeah.
Yeah, I think the point already came up, use them until you can't. It's really important to try. It's really important to, just try, a few of them first. And in fact, and you've just, sometimes it's experimental. I don't think there's any good way to know if you can or can't use them until you try.
Yeah, that's right. Yeah. So if you don't want to just turn them all on one day in the production environment, pick out a few APs that are, in lightly used areas and test some DFS channels on them, give it a few days, see what happens. I absolutely agree though. You need them in a lot of environments. So use them until you can't. I think, the one thing that might slow you down is if you have a enterprise voice client and that vendor recommends not using them. So you might want to engage the vendor and help to understand that. Maybe you can use some, but not all. Sometimes voice clients are a little bit sensitive to AP discovery and how it's a little bit slower on those DFS channels, because you can't go in and start blind probing. You can't, the client can't switch to a DFS channel and start probing until it's heard a transmission from an access point, which is usually it waits for a beacon. So that can make AP discovery take a little bit longer. Only, so much longer that it might affect a voice call. So, and Martin's got the answer there. Just use 802.11k, right? And then you only have these handful of channels to scan, and that can help overcome that. So, but check, if you've got an enterprise voice client, look in maybe they have a nice design guide that can give you some pointers there.
The other thing is to keep in mind, I've run into some issues in the past, especially with some larger clients in Columbus, that actually had doors that were causing problems. So it wasn't specifically a radar event, but it was the actual door mechanism that was sensing people walking by. that was causing all the APs to change channels, making it look like there was something going on.
Wow.
And it literally, it was like, it wasn't radar, but it was close enough that it thought it was. And literally all the APs in the specific building would just go nuts. So just keep an eye out for what's there. And it's typically the weirdest thing that will cause that issue. They'll keep you troubleshooting and looking. So look at your spectrum, look at everything else, and do some testing.
Absolutely. Don't be scared off if you see a couple radar hits here and there either. It's not the end of the world if a few APs change channels every day. You know, as long as it's not frequent and constant and going to be extremely disruptive, a little bit of background noise of radar hits, it's no big deal. Maybe look and see if it's usually on the same channels or it's the same APs that are being affected, and then you can go and alter your channel plan and take that into account. But no reason to freak out if there's a couple of radar events.
Right. There's a lot of DFS channels, right?
Oh yeah.
Awesome. Okay, so the last question we have is going to be for Eric, but before we get into that, I do want to clean up our Q&A panel a little bit here. So Martin has a question. It's actually related to Wireshark, which Jim, I know you presented a couple weeks ago. So during that presentation, it was mentioned that you're using the Metageek profile. When I tried to use that, it did not look to be working. Upon further discovery, I noticed that the wireless view profile was not available in my installation. Is there another version of Wireshark that should allow the wireless feature?
Is there another? I think you're talking about like a legacy feature in Wireshark. Wireshark used to have this like built-in wireless view, and that's been deprecated. So you won't see that in newer versions of Wireshark. I would just say make sure you're using Wireshark 4 or newer, and we can share the link. I think we still have that, Heather, to the profile we built.
Yes.
And it should work though. I did test it.
I'll hunt that down and I'll either drop it in the chat, or Martin, I'll just send it to you directly after the webinar. All right. And then I might need your guys' help to kind of understand the question here, but it's what is roughly the management traffic percentage from overall traffic? Is it a percentage from PHY rate? For example, if a device is connected at 433 megabytes per second, could we say 50% at 5 gigahertz? Does the percentage change based on the current MCS rate? The furrowed brows are really giving you guys away.
Well, the first part of the question with regards to management overhead traffic, regardless of PHY, I mean, you really want to keep that in the single digits, right, guys?
Yeah, you want it to be low, but it's going to be dynamic. So there's always management traffic from beacon frames and from probing. Yeah. And if the network is kind of idle, nobody's doing anything, it'll be 100% of the traffic, and that's fine. It's just there's nothing going on. Once once the network starts getting busy, you want most of the airtime to be available for data and be able to see data taking up most of it. I don't know how to put any numbers around that though.
Trying to figure. I was thinking through that in my head too. I'm not certain.
Okay. Awesome.
I'll agree with Eric though. In a busy network, management traffic should be single digits of the airtime percentage
of the overall. Yeah.
All right. Thank you, panel. All right. We have made it to question number 9, submitted by Anonymous. So this is related to our product. So I'm new to your product. I'm very interested in the expansive list of KPIs. Thank you. In the panel's opinion, which are the top 5 to give the best insight into how your Wi-Fi network is performing? And if different, which KPIs would you recommend engineers keep their eyes on for possible issues that may need addressing?
Well, you set it up in terms of in the context of our product. I mean, obviously our product is, full of KPIs, and the most popular ones that we recommend, that we teach when people have our system, it starts with connectivity. Okay, so we all know that sometimes an access point just wigs out. And so one of the most important metrics that is on our dashboard when we look at systems is something that we call the radio attach success rate. How often am I able to even just connect to this access point? That should be 100% all the time. But if for whatever reason a radio wigs out, an access point kind of goes in the fritz, that could lead to a total wild goose chase, because everything appears to be okay, but people are complaining about slow Wi-Fi. You can't figure out why, and it's because people can't connect to a radio that's right over their head. And so they're therefore sticking way down a very hard problem to catch. But if you're able to just measure, and if you're able to alarm on just the ability to attach, that's a big one right off the bat. Then just, from that point forward, I mean, you want to know, what is the experience? What does the Wi-Fi network feel like? And there are different units of measure, or KPIs, that we use in order to know if people out there are actually having a good experience or not. And that good experience is generally how the network feels: slow or fast, choppy or jittery. And so I would say you would pick one of those that are, that's most important. Ping round trip time to measure latency. But, upload and download throughput, it's just good to see if people are able to just push just a basic number of megabits per second in order to have a good experience. We also measure, we also create a MOS score, mean opinion score, for measuring voice quality. We're basically measuring packet loss and jitter from UDP packets that we send over the network, and basically come up with this characterization of the quality of the voice conversation over Wi-Fi. Again, how does the network feel? So I've got, can I even connect? Then how does it feel? And if it doesn't feel good, if it's slow, fast, or if it's slow or choppy or whatever, I need to know why. And two KPIs that I look at all the time in order to identify what is going on in the environment is, we've already talked about it, guys: airtime utilization and retransmission rate. Those are the two that help me just kind of zero in on, is there some kind of interference in the air? Is there some kind of congestion taking place? So you monitor those very closely. Anybody else want to chime in, Chris and Jim, and add on to what I mentioned in my little short list?
Well, I think we've gone above 5, but I will add to the list anyway. I think MCS rates for sure. I mean, I think radio attach is great to look at connectivity, and then to look at just Wi-Fi performance directly. It's channel utilization, retry rates, and MCS. Keith Parsons calls those the blood pressure, the pulse rate, and the temperature of Wi-Fi. And I think that's a great thing. Just like you go to the doctor, and no matter what, they put the blood pressure cuff on, they check your pulse, and they check your temperature. And it's like, well, I just came in here to fill out some paperwork, but they just do that because it just sets it. Then they know, what your state is, if you're sick or not. And that's a good way to look at Wi-Fi too. Mm-hmm. And I would add, another one that's a good one to keep your eye on, particularly with Sapphire Eye, is the channels that the APs are using. A single graph will show you how frequently your APs are changing channels. Maybe it's expected you're using RRM, and that's part of the plan. But maybe they're changing way too often, or that's going to tell you, the impact of DFS based channel changes and their frequency. So that's a good one too.
And I'll do the flip side of that, is the actual Ethernet testing that we do on it, because that's your baseline. So if that's not functioning, then your wireless is probably not functioning either. So making sure that all the KPIs that we talked about, as far as throughput and those type of metrics are working on the Ethernet side as well, can quickly determine whether there's something else going on in the network. So you're not spending your time looking at a wireless issue when it's actually an infrastructure problem.
That's right.
So you asked for 5 and you got a
10.
lot of bonus KPIs as well.
And then the only thing that I'd like to add is to remember that you and me, we can't see or hear Wi-Fi, but 7 Signal can. Sorry, Eric, I stole your thunder.
Nicely done.
Awesome. Okay. Well, thank you so much, panel. I'm going to stop my sharing. That wraps it up for our Q&A session on troubleshooting. Awesome job. Thank you so much, Jim, Chris, Eric. Thanks to all of you for being here. We would not be here without you. And you know where we will be, same time, same place next week, Wednesday at 11 a.m. Eastern. So we will see you there. Bye, everyone.